Hello, today we're going to show you a way to check if any number is divisible by another number. This method will work regardless of what base you're operating in, but first we must explain what a base is. As you can see on the slide, a base is the number of different digits that a system of counting uses to represent numbers. For example, the base which is used on Earth is base 10. Since Earthlings count using 10-unit digits, ranging from 0 to 9, and then start again from 10, i.e. 10, and then 11, 11. However, this is not the only base system. For example, as shown on the slide, in base 6, you would count 0, 1, 2, 3, 4, 5, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. This base 6 system is the number system used on the planet Camino. Finally, an example of how you would count in base 12 is given below. It is very important to note that the number written as 10, which is often called 10 on Earth, represents the base number. And so, in counting systems that do not use base 10, these numbers should be referred to as 10. Now, we will describe a method for working out whether, in any base, a number is divisible by another number. Firstly, it is important to notice that any number can be written as a sum of multiples of powers of its base. It is very important to note that the symbols 10 represent the base number in the following sections. For example, as shown on the slide, the number 3504 can be written out 3 times 10 to the 3 plus 5 times 10 to the 2 plus 0 times 10 to the 1 plus 4 times 10 to the 0. This way of writing numbers can be generalized for any number x and for any base, such that x is equal to a sub n minus 1 multiplied by 10 to the power of n minus 1 plus all the way down to a sub 0 multiplied by 10 to the power of 0, as shown at the bottom of the slide. It is important to note that each value a is a single digit. Now let's talk about how to find out whether your number x is divisible by some number n. First, you should write out your number x as a sum of multiples of powers of your base number 10. Next, you should work out the remainder when each of the powers of 10 is divided by n, as shown in the second column on the slide. The sequence of remainders is a repeating pattern, so once you see its first repetition, most likely of a 1, you will know it will follow the same pattern forever. Once again, as shown on the slide, these numbers are denoted as x sub 0, x sub 1, all the way up to x sub n minus 1. Next, we multiply each of these remainders by the number multiplying the corresponding power of 10. This can be seen on the third column of the table provided. The next step is to add up all of these products in your third column. If the sum is divisible by m, then so is your original number x. However, if the sum of the products is too large for you to be able to work out whether it is divisible by m, then you can repeat the process using the number which you just worked out as your x number. Now we are going to go through some examples. The first example is in base 10. We would like to find out whether the number 113,022 is divisible by 13. So, the first step is to write it out in its general form, which is denoted at the top of the slide. The next step is to work out the remainder when each power of 10 is divided by 13. The answer to these can be found in the second column of the table. Next, we multiply each of these remainders by the corresponding number that was used to multiply the power of 10 when we first rewrote 113,022 as a sum of multiples of power of 10. The final step is to add up these products and find the answer, which is 65. We can then check to see if the sum, 65, is divisible by 13. 13 multiplied by 5 is equal to 65, therefore we can conclude that 113,022 is also divisible by 13. Finally, we will give an example in base 6. We will check to see if 123,11152 is divisible by 15. The first step is to write out the number as shown at the top of the screen as a sum of its products of its base number. The next step is to find out the remainder when each base number is divided by the number 1, 5. The result of this can be seen in column number 2. Next, we multiply each of these remainders by the corresponding number that was used to multiply the power of 1, 0 when we first rewrote 1, 2, 3, 1, 1, 1, 5, 2 as a sum of multiples of powers of 1, 0. Finally, we add up these products and we find that we get 2, 4, 3. We check to see if this sum is divisible by 1, 5. Finding that it is divisible by 1, 5 in base 6, we can conclude that 1, 2, 3, 1, 1, 1, 5, 2 is also divisible by 1, 5 in base 6. This method holds for all bases, so whether you're training to be a Jedi on Dagobah or running around the sand dunes of Tatooine, you can always work out whether a number is divisible by another number. Thank you very much for watching.